Right on. We finally get a video on reciprocals. You've been waiting so long. Oh, it's finally here. Maybe you're like Mr. Bill right now. You're worried, you're scared about reciprocals. Let's make you feel better. It's okay, buddy. Here we go. Reciprocals. We've been learning about them in class. We've been using them. And we've been doing strange things with them, like decimals and mixed numbers, and that has been a problem. So, first of all, let's remind ourselves what a reciprocal is. Two numbers, when multiplied, give you 1. A simple way to remember this is one number times another number equals 1. And this is always your proof. If you're working on a reciprocal problem and you're not sure if you have the right answer, all you need to do is multiply your answer by the problem number given in the problem, and if they equal 1, then you did it right. If they don't equal 1, you need to go back and check your work. Maybe it was just a simple math error. Maybe you did 2 plus 2 equals 5. I don't know. But they have to equal 1 or it's not okay, and the rest of the problem then will be a train wreck. We don't like train wrecks. They're no fun. So first of all, most of you learned, I'm going to call this a simple example. This is the kind we all know about. Like if you have 1/3 and we say, what's the reciprocal? Most of you learned this earlier in your math careers. You just flip that over, right? We all know that. But most of you didn't learn the proof or the meaning, and so let's take it over here. Once I have two numbers, I think I'm right. I think I have the reciprocal. Let's multiply them and see what we get. This is the proof. You can check your own work. You don't have to wait for the teacher or somebody else to say you're right or you're wrong. You can figure it out yourself. Multiply straight across. When I have the same numerator and denominator, I know that's going to equal 1. The question is how many 3's fit into 3, and the answer is 1. So my proof is correct, and so the reciprocal is 3 on top of a 1. So we all know how to do these, just a little reminder there. Moving on. If we have a mixed number, it gets a little dicey, it gets a little more complicated. Here's what I saw a lot of in class recently, is if we had a mixed number like this, and you remembered, oh, all I do is flip this, you may have done this. Kept the number and flipped the fraction. But the problem with this is, if I multiply these two things, I get some number that's greater than 1. Because this is 1 2/3 and this is 1 and 1.5, and you can tell using your mental math strategies that's going to be greater than 1. So please don't do that. What we do need to do, don't do that. I'm going to take a mixed number here, 2 5/8. First, we need to change it to an improper fraction. We put it into our magical improper fraction conversion device. You might remember this if you start here and go around this way and multiply. 8 times 2 is 16, kind of looking backwards there. And then if we go this way and add the 5, 16 plus 5 equals 21, and we leave the 8 on the bottom. So there, we changed it. Once you change it to an improper fraction, then you can go back to this comfortable method that you've learned in years past and do that. Here we go. Then, it looks great, it looks flipped, but you know what? It's always a good idea to proof it and make sure you're right. So we're going to multiply these two things. 8 times 2 is 16, so that's 168 on top of 168. Those are huge numbers. I don't know if I'm right anymore. What's the question? How many 168s fit into 168? The answer is 1, right on. You are correct. This is the reciprocal right there, 8/21. Okay, so it might not look like it, but these two numbers are reciprocals. Looks weird, right? You may not think that's the correct answer if you were looking at these two things, but if you change this to an improper fraction like we did, then it's easy to see. All right? So when it's a mixed number, change it to an improper fraction and then do the little flip it over trick and then do a proof and check and make sure you're right. Okay? Finally, a third way we deal with reciprocals is when we have a decimal. Let's use this example. Now the key with decimals to fractions is if you can say the decimal correctly, then you can write it correctly, and then you can deal with it in another form, in this case as a fraction. So if I say this correctly, I actually say 6/10. Or Mr. Bill might say 6/10. Woo! And I would write it like this. Now I'm feeling better about making a reciprocal out of this. I'll go 10/6, right? Now it kind of looks like back up to our top up here. Now a strategy we've used time and time again is when we come up with something new that looks confusing, can you work to change that into something that you recognize, that you do know how to do? And in this case, we're just taking these mixed numbers and now this decimal, and we're changing it into something we do know how to do, which is if it's a regular fraction, we know to flip it and it's going to work out. Let's do our proof. 6 times 10 is 60. 10 times 6 is 60. That's the commutative property of multiplication in action. Doesn't matter what order they go in. How many 60s fit into 60? Yes, the answer is 1. So, if I'm faced with this decimal, the reciprocal is 10/6. But, can I make that look even better? Yes. Let's simplify it. We could cut that down to 5/3. Whenever you can, simplify, because most questions will ask you to do something else with that answer, and it's always easier to do math with smaller numbers. That's it. I hope that helps you with mixed numbers and decimals with reciprocals.
That was easy.